the information has to be taken care for for the further the processing, okay, for the analysis purpose. So we'll be storing the information, so the storage will take space as well as the managing all the information for the telemedicine. Okay, so that's what already we know that the few related area we already we saw. So continuing with that, so we'll be looking about the information system. So we know that we'll be dealing with the data. Okay, so the data will be taking, so we'll be transmitting over the medium, so from one location to the another location. So this this will establish the communications between the two locations. So when you have the communications part between the two locations, so we'll be exchanging the informations. When you are exchanging the informations at the distance, two remote two locations, so you'll be looking all the patient data for the further the diagnosis as well as the treatment purpose. So when you look for the diagnosis and treatment purpose, so you'll be exchanging the information. So we know the different types of informations already is like a text, images, so the voice, so the video, graphics, and all those. Okay, so with that, so we'll be having some informations related to the medical records. So the patient details, patient family details, and all those things. Then we have like some surgical robot commands and all those things we can have. So this all can be exchanged in the distance. Okay, so we'll be dealing with the when you have like the surgical things, so you'll be dealing the information related to the patient personal information. So all the data will be exchanged. Okay, so similarly, we'll be looking for the patient's medical information as well as patient management in telemedicine, when they have appointment and all those things. Similarly, we have like the data related to the doctors, those who are involved in this particular organizations and all those things. So we'll have the related data, then data for the system management. So this entire things will be exchanging. So whenever it's required. Okay, so this all will be through the over the medium. Okay, so we know that the different data types we will be dealing in the telemedicine. So when you look for the telemedicine options, so we know that the remote location to the other locations will be collecting. So we can say as a nodal center to the referral center. Nodal center is considering as a remote location. So the reference center we are considering as a headquarter, district headquarter, or some metropolitan city. So in the nodal centers, we know that the group of physicians will be there. So we have the system administrator, data entry operator, and the studio technicians, and the patients will be in the nodal centers. In the referral centers, we have the specialized doctors and the system administrator and the studio technicians. So this we are establishing the connections. So we know that. So when you have the establishing the connections, we'll be looking for the exchange of information. So when you are looking for the exchange of information, so we'll be adopting the standards. So we know that the last class also we saw the different standards and all those things. So for the telemedicine purpose, we'll be looking for the HL7 as well as the DICOM standards. So this we are incorporating together to have the telemedicine practice. Okay, so we have like when you are adopting the HL7 and DICOM standards, so we know that we can widen the scope, so to have the telemedicine practice and all those things. So we have some issues when incorporating both the thing, as well as some not all the organizations will have this adopting the methods and all those things. So similar to data security, so whatever the data we are collecting, patient data is very the important, and we need to secure the data. So the data security as well as the legal and ethical issues. So this all has to be taken care, so that the telemedicine practice will be will be the better solution for the patients. So when you look for the patient personal information, so you'll be having the patient ID, name, age, as well as the state, the male or female. So then they will be having the personal address and all those things. So this all emergency situations and all those things, whom to contact and also this all informations they will be having. Similarly, the medical informations, when you talk about the medical patient informations, so you'll be having the textual. So in that we have the plain text, structured document, image, graphics, video, and the vector data and all this. Okay, so the plain text. So sometimes they will be giving the based on the severity of the patients. So the based on the conditions, so they can be exchanged. So whether they want the information has to be exchanged in the plain text, or they want to look for the structured document. Okay, so this is the plain text. So this is developed by IIT. Okay, so they have the telemedicine laboratory. In that they developed the kind of GUI system. So which has the you can see that the high exposure to the dust and smoke. So this is a simple text, plain text can be given. Okay, with the date and all those things can be given. So this is the example I'm showing from there. Okay, so this is a structured document. So whether the patient's the history so can be given in the structured document. So from where they are coming, the occupations, then what is the material status, then what is the habit, diet, everything can be taken here. This is also an example I'm showing. So the several images can be shared in the medium so that it can be taken. So any X-ray, MRI, CT, all the images can be taken. These are all the vector data. So the vector data. So this is the ECG waveform. So the waveform can be shared here. So whenever it's required, so that can be taken. So we can select the portion of data. So that can be taken for the further analysis. So your GUI system should support to have this kind of interpretations and all this. So you'll be having the enough coding techniques to get the things to be done. Okay. Similarly, we have a few graphics areas, so to identify the skin patches and all those things. So the graphics can be done. So the highlighting, marking can be done with the different colors and all those things, so that it will be taken. So this is a video clipping. So kind of if they want to go for the US ultrasound scan and all those things, so they will be um, they'll be looking. So the movement of the fetal and all those things can be observed. So with this information, so the continuous the images will be getting as a motion pictures and all those things. So you'll be continuous video can be played. So when you are having with this data, so they can go for the analysis purpose. So these are all the different types of information. So then when the patient is coming for the telemedicine practice, we need to have all the data. So when you look for the data, so we'll be this is also developed by the IIT Kharagpur. So they have like the GUI system, so which is going to have give all the data. I am taking an example to show you so how they are developed. So in that they have the sender list as well as the patient ID. You can see here the patient ID and the patient name, and what type of conditions they are coming, whether the like specific things, say example malaria or general. So what specific things the patients are visiting the hospital. So what is the entry date, so when they have the appointment date and so as appointment. So they have whether they are taken the online or not. So this all information has to be kept in um, the patient queue, we can say. So the queue also, it's a form, the 1, 2, 3 like that. Okay, so based on the appointment. So when you want to search for the patient, so you'll be looking for the word specific patient ID, then you'll be taking all the informations. So data related to the doctors, definitely we need to have the doctor's personal informations. So if it is any emergency situations, we need from the organizations, they will be calling and they will be fixing the appointment with the doctor to reach to the facility to give kind of treatments to the patients and all those things. Definitely all the doctors will have the unique identification key, so that can be used to access the authorized areas and all those things. So that key can be used for the several purposes. Okay, so this all information is required. So similarly, we have the data for system management. So in the organizations, so those who are having the user list, we need to have the password file, you need to have log files we have. So who is authorized person? So you need to specify these are all the authorized people. So for them, we provided the password. So only these people they can log in, and through the username and password they can access the entire information. So okay, so log files also has to be maintained. So who is accessing the file, who is accessing the login through which IP address, and all those things has to be taken care. Okay, so the very very important thing is you need to understand. So all the information has to be recorded in the log files. Okay, so only authorized people can enter through the login, so they can access all the materials, not to the everyone. Okay, so I give you example in the later stage. So for how is authorized person and all those things. Okay, then we have like a different telemedicine practice when you are doing. So you'll be adopting the technologies. So the advanced technologies you'll be adopting. So when you're adopting the advanced technologies, so you'll be looking for the in the instrumentation side, medical instrumentation side, you'll be looking. So we need to have the very sophisticated devices, equipments, and other things. And the similar way, we need to have the telecommunication technology. We need to have the information technology. So when you have this three together, so because say example, you have the very good communication path and all those things, but if you don't have the medical instrumentation and the sophisticated equipments and other things, then whatever the biomedical equipment, what result is giving, it should be accurate, right? So we need to make sure that you are working with the very good equipment and all those things. Okay, so there's so through with that medical equipments, we'll be collecting a lot of signals, physiological signals, images. So we'll be measuring the physical parameters like body temperatures, pressure, and all those things. So this all can be taken into the consideration in the medical information segment. Okay, then all the information, so whatever we are collecting, so we'll be giving through the path. Okay, so through the telecommunications path, so we'll be giving. So with that, we have like a transmitter and receiver for the different communications channels and all those things. So it will be taken. So with that, so we can take with the different medium, and we can transmit as well as we can receive the signal. So we can have the wired network as well as a wireless medium and all those things. Okay, so when you're looking for the information technology, so we will be exchanging the information. So we need to have the which information. So the data has to be represented here. We need to store the information. So whenever we need to retrieve the information. So further, after retrieving the analysis purpose, we need to process the information, and we need to have the beautiful presentation. So that is also, it's very very important. So when you look this kind of conditions, you'll be getting all the information technology um, usage. So you'll be processing the information. So this is the medical information as well as the data. So we can have like a kind of system which is going to process all the data, which is going to get the the signals. So then from the signal we will be taking for the processing as well as the presentation. Say a simple example you can say is that you are using some transducer. So the transducer, what is the job of the transducer? To pick the signal. Okay. So from the the patients will be picking the signal, and the signal will be converted into the viewable form, and it should be taken for the processing. Afterwards it can be taken for the presentation purpose. So sometimes it can be taken for the over the medium to transmission purpose also. So this is a medical data information. So example, we can see that the ACG waveform. So ACG waveform can be taken. So whatever the sensors we are using, so it's going to pick the information. So the electrical activity of the from the heart. So the all the informations will be taken. So we'll be after picking the signals. So we'll be going for the different amplifier techniques as well as the adapting the filtering techniques and all those things. Then we will be converting to the several the converters, and you will be looking for the waveform processes and all those things. So then it will be taken for the further transmissions and all those things. So when you look for this waveform, so this is it's shown here ECG. So we have EEG, EMG, a lot of physiological signals around that. So for example, I'm showing here. So already I showed you analog data as well as digital data. So analog data can be converted with the sampling and quantization. So the digital data, so it's a continuous, it's a discrete wave. So sampling based on the sampling and quantization levels. So we'll be taking with the different levels. So the signal bandwidth. So here you can see that what is the response in the signals, how the fast changes it's happening. So this is the slow variations. So the positive to negative. So here we have like a you can imagine the sine wave positive to negative. Okay, so positive peak and negative peak, so like that. So we have here the slow variations as well as the fast variations. So whenever you look for the transmission of signals, you will be looking for the bandwidth range. Okay, so what is the bandwidth range? Okay, so how much the range we can say can have the signals channel. Okay, so next sampling rate is the 2 into bandwidth of the signals whatever we are using. So when you are looking for the different set of data and all those things, so we know that the images, voice, text, all those things will be transferring over the medium. So when you look for the data size for the voice, so the bandwidth will be the 4 kilohertz. So the minimum sampling frequency we have the up to the minimum is the 8 kilohertz. Okay. So we have the bits per sample is 8 bits. So 256 levels will be. So okay, 0 to 255. Okay. So this 0 to 255 levels we will be getting. So when you have this much the 8 bit as well as the 8 kilohertz, then the bandwidth is 4 kilohertz. So minimum data rate requirement is like so 8000 into 8 bits. Okay, so almost 64 kbps requirement is the need for the to have the transmission of the voice. Like that we have for the data, we have like for the EEG signal. So the EEG signal, the bandwidth will come around 100 hertz. So the minimum sampling frequency will come at the 200 hertz. Okay. So the bits per sample here also we are taking as a 8. Okay. So it's almost 1.6 kbps is required to have the vector data. So this is the vector data. The previous one we saw as a voice data. So when you have the video data, so we'll be having the already I told you when you look for the video, so we'll be looking for the continuous images, so the continuous images, so the frames we can say. So how many frames we will be having in the per second. So that is very very important. So we are considering here a 15 frame per second. So when you are considering 15 frame per second, so the resolution of the frame we are taking as a 480 or 680 pixels. So this image we are taking as a color, the video is a colored one. So we are taking as 24 bits. Okay. So this frame resolution frame as well as the number of frames per second multiplied with the bits per pixels will give you the what is the data rate we require. So almost we require the 110.6 Mbps to have the very good streaming levels. So the compression techniques, we will be looking for the different compression techniques. So because we need to get the images. So we'll be requiring the less storage space, as well as that when you are transmitting we require less bandwidth also. So we'll be looking for the kind of data compressions and all those things, but we don't want to lose any important features on the images. So we need to ensure that. So we are when we are looking for the compression techniques and also. So the data compression is mm, one of the important features we have to send the information to the medium. So so you can see that the information is taken here. So you can look here the in both the information. So the uncompressed image we have almost 1 MB. So when you are looking for the same image, it's after compressed we have like a 50 KB. Okay, so it's almost we are reduced, but the important features it's not at all lost here. So we are having all the important features here. So you can look here. Okay. So few informations can be taken here. So the different lot of compression techniques are available. So based on our requirements, we'll be. So the compression standards, so we have like a lossy compressions as well as a lossless compressions. So we can have the different imaging modality. Okay, so the different types of images we have. So that can be taken here. So when you look for the data, so we will be having the zip compression techniques and all. So when you look for the audio, we will be having the MPG. When you look for the JPEG, the still images and all those things, we will be looking for the JPEG and all those things. So when you look for the video, so we will be having the kind of the MPG4, MPG2 and all those things. So here also we need to have the standards. That's what we are saying here. Always the standards are important. So when you look for